Okay,
Thanks.
thank you, David.
Jifeng.
Yes, thank you, David. Can you hear me?
Yes.
Yes. Okay, I'll share my screen.
Yeah.
Let me see. Okay, thank you, thank you. I want to thank the organizer for this wonderful meeting. You know, this is the first time I attend this BRICS astronomy meeting, but I feel so close to you guys because, you know, we're talking about this flagship program we developed together, right? And today I want to share with you, you know, the status of SITIAN and how we want to develop it and how SITIAN and Beijing can develop side by side and hand in hand. Basically, so first I want to say, you know, what is SITIAN? I want to summarize that in 5 phrases. It is an array of about 100 1-meter class wide field telescopes, coordinated by an AI scheduler called a SITIAN Brain, and enhanced with a network of follow-up telescopes, and deployed worldwide for uninterrupted monitoring, and aimed to explore variations in hours and shorter. So basically, it's not just one telescope; it's an array, and it's you know, 100 of it. And of course, I mean, if you have so many telescopes, you need to coordinate them. So you really need to develop something like an AI, like a SITIAN Brain. And of course, it's not only, I mean, this array of telescope is, you know, try to monitor, you know, uninterrupted the whole sky. And once you have some good things, you know, some alerts, you need to follow up with big telescopes. So it's actually enhanced with a network of follow-up telescopes. And also, you know, we want to, you know, deploy that not only in China. We already have some sites for that. We also want to deploy that over, you know, BRICS countries like South Africa, you know, Russia, and you know, we also have, you know, other sites in Chile, you know, in Spain, and Australia and Mexico, even United States, potential sites for that. And we can all realize that once we actually can have cadence in hours and shorter, we can explore a lot of good things, including the NEO, you know, near Earth objects, you know, I think, you know, Boris and Carolina mentioned that already. So this is a good thing. I mean, there are some, you know, essential features of this array. So first of all, it is a standardized units of 3 1-meter telescope with different filters, so that you actually can observe simultaneously in 3 colors. The purpose for that actually is, you know, you want efficiency in identify real variables instead of, you know, false positives. When you do supernova stuff, you know, most of them, I mean, if you just use 1 color and very short, you know, observations, I mean, it's, you know, there are a lot of false positives. You want to dismiss that with the 3 colors. And once you have 3 colors, you actually can derive, you know, parameters, you know, physical, astrophysical parameters of the objects. And you can, of course, at the same time, monitor them. And the unit, you know, I mean, the telescope, you know, you know, what we want to do here actually is standardize. I mean, because that means a lower cost. I mean, now the design actually is have you know, 5 degree by 5 degree field of view telescope, and we want to have like 4, you know, 9K by 9K CMOS, you know, mosaic camera. I mean, I actually, you know, have the full design, and I actually have asked the factory, you know, the industry, I mean, what's the cost for that? We already have the technical, you know, forces, the teams to actually make the camera, the CMOS camera, and also, you know, manufacture the telescope. And the current instrumentation cost is something like 20 million yuan. That's roughly like $3 million US. You can compare that to Zhuhai Transit Factory. I mean, the renovation of its 1.2 meter telescope, the instrumentation cost is something like 10 million, I think. And of course, I mean, you know, they actually, you know, raised fund, you know, another 14 million fund for, you know, operation and labor. I mean, once a further step for us is try to reduce the cost. I mean, now it's a 20 million yuan. We want it to be 10 million yuan. And I can already see how we can go there. I mean, now it is an array. It's not one telescope, right? If it's one telescope, you discover things. I mean, if you have an array, you actually, you want to stare at things. So what do you need? Actually, is an array of 24 units, of 3, color telescopes at one location, and then you actually can cover, 600 square meter in one exposure of 2 minutes. That can give you something like a 21.5 magnitude, detection threshold. Well, and if you want to cover the whole sky overhead, is something like 10,000 square degree. That's just 30 minutes. So that's why it's, once you have such a array, you actually can monitor the whole sky. You can have a cadence of half an hour. So the current idea, now, I mean, in China, we are pushing for SITIAN project phase 1. We want it to be, 2025. I mean, basically, phase 1 means about 100 standardized 1 meter telescope. I mean, the cost is something like a 1 billion yuan. Of course, you still need a SITIAN brain and a follow-up network. It could be another 1 billion yuan. Well, this phase 1 array will deploy mostly in China, but I also want to put some units, in BRICS countries. Well, the total cost is something like 2 billion yuan. It's the size of a mega project in China. So every 5 years, it will be selected, among all disciplines, including like astronomy. I mean, previous mega project examples, the most, telescope is a larger scale area, multi-object fiber served telescope. And the second actually is the FAST, the 500 meter, radio telescope. So, and then the third one we are pushing for actually is a 12 meter, large optical, telescope. We want this one to be a force. So, I mean, here I put the table here. I want to thank Roberto for putting this up. So basically, you can see, when we compare SITIAN with, say, LSST. LSST is effectively, something like a 7 meter telescope. I mean, it's 8, of course, but the effective area. But it can, given its large aperture, of course, it can see very deep into the universe. But then the cadence is something like, weeks, several weeks. It's a week, something like a week. So basically, we want to emphasize, we have a very short cadence and we cover a huge sky. And if you stack all the images, over a period of time, it's kind of similar. It's a little bit less than LSST, but something, close, just because it has effectively a very large aperture. I mean, so when, like I say, it's 2025. Why? Because either it is very fast, it is very fast, you do it, you push for it, or either it's never, it will never happen. So it is 2025. I mean, to do this, of course, I mean, the main thing actually is you really need to gather enough momentum to make it happen, right? What do you need? You need people, right? You need money, you need technology. So for people, we already have an active SITIAN consortium in China. We have something like 100 researchers from 24 institutes in China. That's essentially all institutes in China. We already get a 2 million yuan startup grant from NAOC, from an institute, to actually try to push this forward. We have this draft white paper ready already. It's in Chinese though. We are aiming at an English version in a year or two. And most importantly, I have spent a year, more than a year, to actually to look around, China and all the institutes, not only astronomical institutes, to see whether we actually have the technology ready. And now I can say we have the technical team, and we already have the design ready. It's not to say it's fixed, it's the final design. At least we have some feasible design already. And we have the sites in China ready. Here I show, the Lenghu site in Qinghai province. We actually just convened like a month ago in Lenghu, just some of us, because of the virus situation, there are travel restrictions. So only, around 30 people, actually convened in Lenghu. I mean, the local government already prepared a site for us. They actually chopped, a mountain top to a table mountain, like in, Cape Town, on the top is something like 150 meter by 30 meter. It's enough to, if you want to deploy like 100 or even 200, it's enough, side by side. Other than this one, we already have Mushtaq site, and we also have potential sites. We have some collaborators, international collaborators, they're interested in this program, and they ask whether we can actually, deploy some telescopes there. We will actually collaborate, further. And when I say, consortium in China, we really want to say we embrace international collaborators to form a global consortium. I guess that's why we get here, to talk about BIDIN and further, and the phase 2, like a SITIAN project. And also technology. I would say, technically ready, in a sense that for the optical design, we have one feasible. I think maybe we'll adopt that in the future. It is a 1 meter modified Schmidt design. It's designed by Nanjing Institute of Astronomical Optics and Technology. They specialize in astronomical optics. And the current cost, estimate of cost, is 12 million yuan. And then for the camera, we want to use a mosaic camera with a 4 9K by 9K, CMOS detector. Both G-Sense, G-Pixel, both G-Sense and E2V, actually have contacted us. And for G-Sense, they already have this 9K by 9K CMOS. And NAOC actually got one today from them. And E2V actually are planning to send us one next year. So the current cost, when I say current, because 9K by 9K CMOS is still in the early stage, so it's very expensive. So the current cost actually is 8 million yuan. The total is something like 20 million yuan for one telescope now. My goal actually is reduce the cost from 20 million yuan to 10 million yuan. In 2 or 3 years. And then for SITIAN Brain, and we already have this core team from NAOC, but we really want to welcome all collaborators from all BRICS countries and all international collaborators. I mean, because we want to combine the technology, combine the resources. So the prototype. So how can we move on? I mean, you have the technology, you have the people. Where do you get the money? Before you actually get this 2025 mega project, we plan to do 2 things. The first thing is to build 1 unit of 3 prototype 1 meter telescope. I mean, because each one actually is 20 million yuan. I mean, we need 60 million yuan. I mean, currently, I'm from my institute, NAOC, I actually expect 40 million yuan, in 2 years. So that means, I actually can have enough funds to build 2 prototype 1 meter telescope. And then now I'm actually searching for, another venue to actually get another, 20 million yuan, maybe from, the Minister of Science and Technology, and through the help of our collaboration with them. I mean, because I actually ask around, and they say, we have this, within BRICS, we actually have this bilateral and multilateral collaboration, from our most and your most. So I think, that's one way we can try. Another thing, I mean, this is actually, what I try to do actually is build an array of smaller telescopes. If the first thing actually is to test the telescope, the 1 meter telescope itself. The second thing actually is, to test the array, how you can use STEM brain to coordinate in a whole array. I mean, smaller telescope, I mean by this, it's one thing I actually already have one, actually is a 50 centimeter telescope with 3 color CMOS camera. So I have 1 telescope. Then I have, 2, dichroic. So I have a 3 CMOS camera. This one actually current cost is 1.5 million yuan. It's pretty low because we actually, manufacture it. I mean, it's affordable. The good thing for this actually is it's affordable to high schools. What I'm doing now is I'm soliciting high schools to build such telescopes, and then they will deploy that at Lenghu side and Mushtaq side, or maybe also in BRICS in BRICS countries. So why they want to build this? Because our SITIAN consortium actually will supervise their students in exchange. So what I'm doing actually, I try to establish a model, so where we can combine, science and astronomy and the community together to develop this array of small telescope. And all of us
can try and wrap up in a
yes,
few. Sorry, 1
minute actually.
Okay.
So I'm saying, we are actually developing this model, and it is actually successful. So that's the status. So, I want to, actually I want to conclude here. Bidin and STEM, we should develop together, side by side, hand in hand. This is really for everyone's good. So I'll just stop here. Oh, by the way, Dr. Peng Bo, want me to, tell you guys, say hello. He's, he will join us tomorrow, but now he actually is in the shuttle to fast site. Okay, thank you.
That's very much, Jifeng. That was most illuminating, and I'm really pleased to see how the project is developing and growing. So maybe we'll have some time to discuss at the end, but I think we should move on now to the next speaker, which is Amitesh Omar from the Aries Observatory in India. Amitesh,